All right, welcome back. So this will be the third video for Module 2. The first one we kind of hit the ground running. The second one, I said, here's our first assignment, the first notebook that we're going to be dealing with. And now this one, we're actually going to jump into the code, and we're going to get into some coding, deal with notebooks, and we're going to progress from there. Now, in this lecture, I'm going to walk through a presentation by a colleague, Christian Garvin, presented at an IEEE conference a few years ago. It's for machine learning applications. And he's got a great GitHub repository that explains the fundamentals of data science. It starts out with what we're going to deal with in this first assignment, exploratory data analysis. So with that said, our textbook, it's the second edition. I've got a number of resources here from Jake Vanderplas that are founded upon the first edition. There are differences between the first and second edition, but conceptually, there haven't been significant changes conceptually. It's been fine-tuning from the first to the second. Along with that, I've got this Python cheat sheets. For some, this may be a great resource. For others, yeah, that doesn't work for me. Now, I've got 9 different pages of Python code, I can't remember how to do something. These are great go-tos when it comes to coding in Python for data science. Okay. With that said, they're great resources. Over time, the best thing that you can do for you when it comes to data science coding, AI coding, using Python is hands-on. The repetition. I often make the analogy to going to the gym. It's nothing like spending time in the gym and putting the time in, getting the reps in. Now, that doesn't mean that you've got to go do a ton of heavy lifting. That light lifting every day and over time increasing a little bit, and you don't notice how much you've gained over time because it just seemed like it was just light lifting. It was light lifting, but it made a huge impact. So the more light lifting you do, the little things where you go explore. Let me go look at this object A. What is the shape of A? A happens to be an array. What are the dimensions of it? What's the shape of it? And we'll go into these things. This isn't a programming course per se. This is a computer applications course, so we're applying programming concepts using a specific application, a programming language of Python, and different libraries. So we're applying Python to data science. Now, there's an expectation, as I said back when you started the course, that you have the basic foundations of programming. It may not be fresh. We've got some that have taken intro to programming years ago, and they haven't coded in years, and things have changed. They may not have coded using Python. As long as it's still object-oriented programming and you understand the concepts of object-oriented programming, we're creating instances of classes. The float class. I want to make a float. My float inherits all the attributes and functionality of that parent class, and I can call it whatever I want. I just mentioned that instance of an array called A. Here's an instance of an array, NumPy array, we'll call it A. Here's another one, we'll call it B. Another one, we'll call it C. And we determine what we're going to put in it. In this one, we typecast what's going to be in it. It's an array of floats. These are implicitly integers. Explicitly floats. So, if you're not fresh in programming, spend some time. Go through, see if we can find different resources to get you caught up. We've always got resources in the Learning Center, SLC, and that'll help you. Okay, so we've got cheat sheets for the different libraries we're going to be using. We're going to be using Pandas, we're going to be using scikit-learn, we're going to be using MATLAB, SciPy. So whatever we're going to be using, here's one for NumPy. Keep these handy. Every resource helps. Okay. So with that said, we've got our cheat sheets. We've got this companion code. And I'll open a new tab. Let's go look at what Jake Vanderplas has for us. And here we see a GitHub repo. The author of the text has created for us. And here's his README, where he tells us he's got a 300-page PDF explaining all the ins and outs of this data science handbook, running Python code, the how-tos. Okay, so if we jump into these things, this will take me to that first whirlwind tour of Python. Here's your great refresh on Python. Okay, so as we go back, get strong in Python. Cheat sheets to help you remember the little ins and outs on Python. We're walking through this little guided tour from the first module to where we are now. We've got our step-by-step. You went through and set up your Colab. You went through Kaggle and got caught up, familiar with Python. There's other places to get caught up, and I said, here's this one that we just jumped into, Jake Vanderplas's whirlwind tour of Python. So getting caught up with Python, everything we can do to get caught up with Python, they're all pluses. So there's no expectation you're going to be a pro at Python walking into this class. We've got some students that are very strong in Python coming into this course. Others may not be as strong. This is the time to put the effort in and start exercising in Python. Get familiar with the use of Python. I'm not saying that, oh, you've got to jump in and you've got to get great in the next week. That's not the case. One of the things that we had in that first module was the discussion. Get familiar with others in the course so that we can help each other out. Everybody that's in this course is in it together. Same goal. Tools in the tool belt. Okay. So everything we can do to help others along the way benefits us as a group. Get strong in groups. We just look at it like we're going to the gym together. All right. So we've got that. Let's get started in data science using Python. We've got our cheat sheet resources. We've got the whirlwind tour of Python that Jake Vanderplas has got for us to get us up to speed in Python. We've got Christian Garbin's resources that we're going to go jump into that help us with understanding the application of Python in data science. What is EDA? All right, we're going to jump in there very shortly. As we come down, there's the two files that we're dealing with. Test.ipy notebook. That was the one from the last module. That's what you're using in that guided tour. salaries.csv. That's what you're going to be using in the first assigned notebook. Okay. So this is what you're going to need to set up in your Google Colab, or I should say in your G Drive, so you can access it in Google Colab. And as I noted in that intro to assignment 1, and keep in mind that intro to assignment 1, as I explained then, is here's the first assignment. There's no expectation that you need to start working hard on it today. It's just a heads up. This is what you're going to be working on in the coming weeks. It's not something you're going to get done in the next day or two. It's going to be worked on over time. Rather you have access to it, and as we're going over the concepts, you can apply them in that notebook as we go through it. As opposed to, all right, we're going to go through it. Now here's an assignment. I hope you remember everything that we've been going over. So let's, as we go, you've got the assignment and things will start to come to light. And you can ask questions as we go through it in the discussions. Hey, I'm running into a problem with this, whatever it may be. Okay. A couple more videos on a Jupyter Notebooks, and you can use Jupyter Notebooks in Visual Studio or Visual Studio Code. I commonly do. It's a great IDE. You can get it Microsoft for free. Right. So you don't have to go through. Let me back up. We're using Google Colab because it's a one-stop shop. You don't have to have a expensive AI-based or designed for AI system. You can run your code on the cloud, and that's what we're doing with Google Colab. We're running our code on the cloud. We don't necessarily have to do it on the cloud. We can do it on our standalone machine, and there's a variety of ways to do that. Since we're using Jupyter Notebooks, there are a number of ways, but the number gets smaller. If we were just running Python code, the file extension .py, there's a bunch of IDEs we could use. But when we get into the IPy notebooks, the numbers, they shrink down a little bit because of how the files are configured. So one of the things that's commonly used is a platform called, or a group of applications called Anaconda. And Anaconda allows us to run Jupyter Notebooks on our standalone machine. Now, what that means is your machine is going to have a processor that can do the work, that can process these really large data sets if needed. Not something we all have. If we're dealing with Anaconda, one of the common hurdles with Anaconda that I've run into, former students have run into, is keeping it up to date. And by up to date, I mean these libraries that we are going to use are very dynamic. They're constantly being updated. And they may not be backwardly compatible. So what that means is, let's say I'm using version 3.1 of something, but the current version is 4.9. And 4.9 may not be compatible with 3.1 code. I may have to revise my 3.1 code to use 4.9. Now, if you're running on your standalone machine, what version are you running? You may have to update your version, and by updating your version, that could change some dependencies that are taking place in there, and it gets cumbersome at times, keeping track of versions. If we run on Google Colab, we don't have to worry about that so much. We're all hopefully running the current versions. Now, with that said, we can run Visual Studio Code, and we don't run into the problems as much using Visual Studio Code as we do if we're going to run Anaconda. Now, what we would end up doing, and sometimes we've got to do it in Colab, is we have to update whatever version of a library that we're using. We may have to install the library. Now, we'll talk about this in a little bit. So yeah, let's go ahead and install this library. We'll include this library depending on the syntax of the language, whatever we're doing. That's all well and good, but we have to have access to it to be able to use it. And the commands we use, it's traditionally a pip code to install that library. Just, all right, here's the library, let's pip it in. Once it's been pipped in, we can then utilize it in our little housekeeping section that I'd mentioned in that intro to assignment 1. Okay. So here's a little walkthrough on Visual Studio Code and Jupyter Notebooks. So let's jump in and go back to, here's our starter. Remember, we're going to deal with EDA. And EDA, at least at this level, the first 2 assignments are dealing with EDA. The first one, we're not jumping deep in the pool. We're going to start off in the shallow end, let's say. We're getting familiar with the interfaces. We're getting familiar with the code, getting familiar with the expectations of the course. That's this first assignment. Now, in this first assignment, we are exploring data. And this is not complex data. It's widely used data. Much of what you'll see in this first assignment is readily available online. And as I noted before, we're not recreating the wheel, but we do want to give credit to where we got our inspiration from. So our inspiration could be what I'm going to walk through in a little bit. It could be Christian Garbin's explanation of EDA. Hey, Christian had this code. Well, let me go ahead and when I'm putting together mine where it says, all right, here, go enter your code. You know, I can come in here, inspired by whatever it may be, and then put the URL in there so that whoever reads this says, oh, so he's utilizing that code that was created, or the source for what he's doing here, she's doing here, came from this. As opposed to trying to represent this as all original code. Much of what we're going to do in this first and second assignment is not going to be 100% original. You're not recreating the wheel, as I said. You're applying these tools that exist to a given data set. You're going to personalize your code. You're putting your comments in there, explaining your perception of what you are doing in your code. Okay? So make sure inspired by where it came from. All right? This stuff's everywhere. There's a textbook, common textbook in data science using R that has this data set doing much of what we're doing. Conceptually, same thing, but it's a different language, so how you go about it is different. Okay. A lot of times, you'll go look and see what somebody else doing, not because you want the answer, you want some insight because You're wanting to make sure, am I on the right path to get where I need to be? Or you feel that you're at the destination. I got where I needed to be. I did the job. How'd somebody else do it? Oh, I could have gone further. Oh, I didn't think about doing it like that. So there are different perceptions on what that destination may be in different levels of or different degrees of detail. Okay. Don't overdo it. I can't emphasize that enough when it comes to this. Make sure that you address the bare minimums first. Once you've got the bare minimums addressed, then go beyond. So there's bonus points in here. Get the stuff you have to have done first, then go to the bonus points. Sometimes the bonus points may not be difficult for you, and some of the basic stuff may be. If you can knock out a bonus point aspect of it easily for you, jump into it. But don't burn time on bonus, fighting on the bonus points when you haven't got the first 100% done first. Okay, so let's go look at Christian's repository. Okay, so we've got the README that explains, here's what we're going to do. And he walks through, and let's clone his repository. We can go look at whatever we want to look at, and we're going to focus right now on exploratory data analysis, EDA. He's got a notebook that's just about EDA. And in EDA, we have a data set, and we're going to look at this in two phases. The first phase, I mentioned, we're in the shallow end of the pool. Second phase, we're getting deeper. So our perceptions and what we're looking for are going to change as our skill level, how deep we get in the pool, changes. So we're going to use functionality that exists. There's described functions, unique functions, is null functions, the head function. These functions will return values associated with a data frame or a frame within a data frame. So we're going to use Pandas to read data in. We're going to keep it in this structure, if you will. And we think of this structure much like, if we try to visualize it, it looks like an Excel spreadsheet. But we call it a data frame. Okay. So let's go look at Christian's first notebook, or notebook number 1, relative to exploratory data analysis. So we have access to data. And our first goal when it comes to EDA is that we want to understand and trust our data. So we're getting data from somewhere. Where? I don't know. It could be coming from just about anywhere. I need to know where the data came from. Is it complete? Is it reliable? Does it represent what I think it represents? So we've got a perception. Is that perception real, or is it misguided? How accurate is this data in representation of what I'm trying to analyze? So I need that level of expertise in the domain to be able to understand the data. It's almost like that idea that you need to be familiar with a conversation before you start talking. Know what you're talking about before you say something. I need to know what the data is about before I start trying to answer questions based on it. Okay. So this data set, a lot of this is what we're dealing with in that first assignment, comes from an R for Data Science textbook. Okay. You can use that if you're inspired by what Christian's done here. Great, cite it. The URL posted. You can be more specific and point to this first chapter notebook. Okay, so we got to start out by importing pandas. So here's a library that we're going to use. If I don't have pandas, I'm going to have to pip it in. Traditionally will not have to do that. So we're going to import pandas as PD. Why do we call it PD and not pandas? It's just to save a little bit of typing. It's a common abbreviation. So using the PD or pandas library, within that pandas library, so there's the period, pandas library, within it, there's this function, the read underscore CSV. There's a variety of functions that are read functions. This is specific to the data type or file structure of CSV. If it was a .txt, whatever the file extension was, you would have to have a function designed specifically for that file extension. Use the right tool for the right task. The task, read data from a CSV. The tool we're going to use is a function. Pass it that file, and we give it the path. We read it in. Now, in the notebook, and we'll deal more about that later, I had mentioned in the previous lecture where I introed that first notebook that your file path has to be dead on so that it knows where to go look. Okay. So this is not written in a manner to connect to your Google Colab and your G Drive. This is written as a standalone. It's in a local folder, and we're just reaching out. Our notebook, our IPyNB file is local, and we're running it in a local CSV that's in a subdirectory of data. Okay, so we're going to connect in a slightly different way, but we're going to use the same tools. So we're going to have some steps in between here to get our salaries data frame. Okay, so we've got the library. The library is going to help us get where we need to be. We've got to connect to the source. Here we're saying the source is local. If I jump back over here from Google Colab, so this is where we mount our drive. Make sure that once we've mounted our drive, that same task is taking place here. This line right here. That's it. That's the same thing that's happening here. The only difference is the path. So in our task, you'll mount your drive. Once it's mounted, you'll go ahead and pull that data in. Okay. Make sure the path is the same as this so that when your instructor goes to run this code, they have their salaries.csv in the same path. Okay. So as we move forward, we've got our library. We've used that function to read in the data in the CSV file, and we've stored it as a salaries. It's a data structure. It's like a data type, but it's structured data. It may have multiple data types in it. And we call that structure a data frame. As I said, it looks much like an Excel spreadsheet. So when we come down, at this point, we can use the Python built-in function, the type function, to tell us the data type of salaries. If you're curious about what data type anything is, it's real easy. Print, type, pass it what you're unsure of. The system will let you know what the data type is. Okay. So this data type, when you know what it is, and you have to know what it is, then you know what tools to use to access it, to do the work you need to do. Okay. So we have this object. It's an instance of a data frame. It's called salaries, object-oriented programming. We create an instance of a pandas core frame that's a data frame, and we call it salaries. Now we've got a salaries object, and we can do whatever we need to do with it, and we have associated with this salaries object attributes and functionality. All right. Knowing that, we can go dig deep into this data frame to try and get some insights. What's going on in there? All right. So there's a shape attribute associated with that object. The shape is two values. The first one is how many rows. Second is how many columns. So I can say rows, comma, columns equals salaries.shape. So we took this shape, which is two values, and we put it in rows and columns. So let's go ahead and print out. The data set has this many rows, this many columns. First parameter, rows. Second parameter, columns. So we're using the format function to format these values as a string. In between two quotes, this is all a string literal constant, but we're saying, hey, I'm not sure what's going to happen here. Format whatever's in this and put it there. Oh, what's going to happen in between these curly braces? Get whatever's there, format it in here. All right. Here's the result. The data set has 1,192 rows and 6 columns. Rows are like records in a database. Columns are like fields in a database. These columns in data science, we call them features. Okay. Each feature has a value from one row to the next. So what kind of information are we looking at this point? What do we have? Well, tell me, what are the columns associated with salaries? We got them. So it's going to go get those columns for us. Now, it told us that they're formatted as objects. These objects are strings. So I have a list of strings. When we say a data type's an object, a string is an object. There's a string class. We've created an instance of it. And here are instances of strings. So these are all of the features. The columns are our features, what we're looking at. Now keep in mind that sometimes the names or the labels, if you will, that have been assigned to these columns or our features may not accurately represent what's in there. All right. ED, depending on context, ED could mean a number of things. In this, it's your level of education. Is it the grade? How old you were? So we have to understand these values. Height. Are we talking inches, feet, centimeters, millimeters? We've got to understand the unit of measure associated with whatever that feature is. So we've got to understand what's going on in the data. So when we go back up in exploratory data analysis in EDA, we want to understand and trust our data. How well do we understand this at this point? We're just dipping our toes in the water. We need to understand step by step what's in there. Now, a lot of data sets will have a file like a README that goes along with it that explains what's there. Now, if we don't have one, we need to create that so that there's some understanding of or consensus on how this data is represented, where it came from, what it is. So one of the things that you've got to do in that first assignment is you got to explain each of the features. What is it? What's it about? Oh, it's an annual salary. Is it in euros? Dollars? Do we know? Height? Maybe in inches? What are the digits? So Christian's gone through and created a little description of what the features are. So now we've got an understanding of what we're dealing with when it comes to the features. We may have to make some changes and change it from a word to a categorical value, 0, 1, and I've referenced this in that second video. Race, we may want to change that as well. Okay. That's something we'll deal with as we get to it. Now, if I said, what are the data types for the features in salaries, the columns? Print salaries dot data types. Now, data types is not going to be for the rows, it's the columns. Earn is a float. Height is a float. Sex is an object. What kind of object? It could be a string, it could be a list, there's a variety of things it could be. And that's one of the things we want to, at some point, convert that from an object to some numeric value, a categorical value. Education, age, race, and we could rename these if we want to, and we'll deal with these things as we get to them. Are we missing anything? We need to know, are we missing anything? Now, if we're talking about floats, floats are represented, if it's missing, it's represented as not a number, NaN. So we need to check for NaM, or is there a null value there? One of the things that we'll need to do is go through, say, look, are there anything missing? So salary.isNull, and add up all the values, the total of how many we found that are null for each feature. All right, we see there's something there for each one. So we're good. If I didn't run the sum, it'd go through and say true or false. Is it null or none? NaN. And said, no, it's not. No, it's not a number. So they're all false. You count up how many would have been true, and that's what we get. So sum of true values for that is null. And we see what we get. Okay. Now, one of the things that we're going to want to find out is we'll look at basic statistics. Now, like I said, this is not a statistics course, but at this point you should have a foundational understanding of some statistics. The ability to count how many are there. 1192. What's the mean value? It's the average. What's the standard deviation? It's the minimum value, the maximum value, and then the quartiles in between. Now, as we go through each one, we can get different insights from the summary statistics. And this describe function will give us summary descriptions or summary statistics for these values. Okay. Now, it can only give us summary statistics on the features that are numeric. So remember back here, we had a couple that were sex and race were objects. They were strings. They weren't classified. Excuse me. We didn't have them as categorical values. So sex and race are both categorical. Moving forward, once we've done that, but for now, they're just words, and I can't get statistics on words. Statistics on numbers, we can. So this gave us descriptive statistics on the values that were numeric. So there's some insights. We can go through and get some more insights. Say, all right, let's look at this salaries object, this data frame, and let's focus on the sex category and tell how many unique values are there. What are the unique values that we found in the sex feature? So that's that one column, the feature sex. And it says, well, you've got two options there. How about race? There are 4. Okay. 01, 012. It's possible. So we can change things around a little bit and right here we're saying let's round it down to 1 decimal point. I want height rounded down so it's not some really long number. So we're starting to pretty things up a little bit. Does it change what we've got? And there's the statistics on it. So let's go look at the statistics for height. Before we looked at the statistics for everything. Now it's just the descriptive statistics for height. Gives us some insight. It's the max, the min, the average. So as we've gone through this initial EDA is a glance. I haven't made any hypotheses when it comes to the data. Just looking at it, saying, what do we got? What are we dealing with? And as we move forward, we can continue to explore and we can start wrangling the data or cleaning it up a little bit. So we can maybe get more insight from it. Sex and race. It's difficult to get insights when those are objects and not set up as categorical. All right. So at this point, let's jump back and we're going to go start looking at the second notebook that Christian's got here for us. So we've looked at the initial glance at the data. We've looked at the initial EDA. We're going to go in and start looking at some things. Let's see how far we're going to dig into this. I don't want this video to get too long. We've got time to get through this because, as I said, that's first assignment, first notebook we're dealing with. The assigned notebook. We've got a while to get through this. So we're going to look at the statistics. We brought the data in as a data frame. We use that head function. The head function will give us the first 5 rows. What if you only wanted 2? Put 2 in there. Pass the head function the number of rows you want returned. The default value is 5. If I said salaries.head 2, it'll give me 2. Salaries.head 10, it'll give me 10 rows, the top 10. So if I told you display the first 6 rows, salaries.head 6, and there you go. So this is stuff that we've done. We went about it a little bit different in our notebook because, as I said, we mounted the drive and we used our path. So we're going to import matplotlib, and not just matplotlib, we're going to get pyplot from it. And we're going to reference this pyplot library as PLT. We're going to import Seaborn. We're going to reference it as SNS. So it'll be PLT dot whatever the attributes, PLT dot whatever the functions that we're going to use. And same here with SNS. SNS dot attributes, SNS dot the function. And then we're going to use this matplotlib in an inline representation. Okay. So as we go through it, we need to clean up our data a little bit. So we've got the age. And do we look at age as, if we ask somebody, how old are you? I'm 3.2. I'm 33.5. We traditionally don't do that. We try to use whole numbers. Age is a float. Okay. We can do that. We may want to look to see, is this skewed? We may want it skewed. I'm not going to dig deep into that, but we look to see, when we say skewed, if we visualize the age. And here's a histogram plot. So we're using a Seaborn histogram plot function. We want to plot age from salaries. We're going to look at density as the statistic, and we set KDE as true. Now, I don't have to dig deep into this now, but what we're looking at is age and the density. The density is how many at that given age. And we see when we're looking at the distribution, and that's all this is a distribution plot of the different ages. We see that it is skewed one way. Now, so what do you mean skewed one way? All right, the ages pretty much go from 0 to 100. they're skewed to the left. 78, almost 79% of them are below 50. And we're talking about the density. So it's skewed way to the left. Is that important? We just need to know it. That, hey, most of the people are going to be under 50. Is that a big deal? Is that representative of the population that we're dealing with? It may or may not be. Okay. So this visualization helps us get an understanding of what we're dealing with when we're looking at our data. So we want to take the data that we've got. Let's go look at it. Let's visualize it. The more we can visualize things, the better understanding we get of what we're dealing with. So there's a histogram plot. Now, this one's a box plot, and it is pretty much doing about the same thing. And we said, let's take salaries.age, we'll put it in X, passing X, which is an array of the values. We pass that to box plot, and that is how we can visualize how it's skewed. Wow. Here's everything from one end to the other. Most of it's right in here. Okay? It's another way to represent the data visually. Okay. What if we said, you know what, there's some outliers. I want to get rid of certain outliers, the really old ones, the really young ones, because they're that's outside the norms. We'll say those are the outliers. I may want to drop them off or cut them off. And if I do that, does it change things? It shifts things a little bit. So we got rid of 120 employees that are over 66 years old. Now we're only analyzing 1,072. Why? Well, I got rid of the outliers. Those people aren't actually working. Okay? Or they're working, but they may be self-employed, whatever it may be. So I may want to get rid of some of the outliers to get a more accurate representation of the data. So we can go through and we can clean up different columns. And if we clean up the education column, let's see what's going on here, and we see most of them are from 12 to 16. So they got to high school and the first 4 years of college. If I want my cutoff at 12, so I don't want to deal with those that didn't make it to high school at the end of high school. And I cut off the ones that are below it, less than the cutoff of 12. Boom. Now one of the things, all caps is a constant. We set that constant value and then we use that. If we change the value of that cutoff, we only have to do it in one place. And anywhere it's used, it's reflected there. So we can go through and clean up different values. Check to see, is the data set balanced? And by balanced, we want to see relative to males and females. So I can display age, and I see this for males and I see this for females. Like, wait a minute. We've got more females at certain ages. We've got more males at certain ages. Is that important? I don't know. But at least I have the ability to understand what's taking place there. I'm not trying to infer some hypothesis at this point. I don't have any. I just want to be able to look at the data and see what's there. At least now I know the density of males and females at certain ages. I can look at the density of everybody, but at certain ages. But maybe I want to break it down by male, female. Maybe I want to break it down by education level. That's a thing too. So I can change how I've got it set up. Here it is by education level, from 12 to 18. All right. And we see that it gets to be about the same distribution, male and female. But when we're back here, we see there are fewer males at the different levels. Now, this just helps us take different looks at the details. Now we're going to dig into a cross section of a lot of different details, and we're going to use a pair plot. And it's salaries doing a pair plot against the other features and sex. Sex compared to earnings. Sex compared to education. And then we're going to look at it in different perceptions. All right, here's earnings and sex. Blue's the male, and the red's the female. There's a distribution by earnings and age. Earnings and education. We can just go each direction with it. Okay. So from there we can go through and show the different combinations, what they mean. Maybe I want to go through and get an understanding of the race by gender. This will tell me the different races by gender. It could be important depending on the questions I want to ask. So as I come up with different questions I want to ask, I have to be able to visually represent the data to be able to answer those questions. Okay, so as we go through this step by step, that's all we're doing is digging a little bit deeper into the data and seeing what we can see. We're not trying to answer any questions at this point. We're just trying to, let me visualize this. And I may say, you know what, I kind of like the way this is laid out in a box plot, but we need to tweak this a little bit. Maybe I want to rotate the x-axis labels. Maybe I want to group it. There's different things that I may need to do. It's, as Christian said, man, this is awful busy. So we may want to clean it up a little bit. And here we've gone through and we said, let's group this thing up into bins at different levels, 1 to 21, 26, 20, right on up. So now we've got groupings. It's a lot cleaner, isn't it? Go through, look at education level. Cleaner. Let's get rid of the low salaries. We're digging in deeper. And we're just going through using different functions to visualize the data and passing it values. What is it we want to compare? What's on the X? What's on the Y? What are we looking at? I want to be able to differentiate male and female. And there we go. So from that, we've got our conclusions that we can come up with at this statistical at a glance EDA. we're not trying to answer questions at this point. We're just trying to get this data represented in a way that we have the ability, if needed, not far down the road, to answer some questions. That's going to be our initial goal of that first assignment, is get the data cleaned up, get it in a way that we can visualize it so that, can we answer any questions? When we get to the second notebook, we're going to answer some questions. We're going to come up with hypotheses and go see if is our hypothesis right or not. Okay? So let's cut this one off. We're right at an hour. And we'll leave the next ones over to Module 3.